Hey everyone, and welcome. Today, we're diving into a pretty heady topic. The idea that even mathematics, often considered the bedrock of objective truth, might be subject to the postmodern critique of metanarratives. Specifically, we're going to explore how Jean-François Lyotard's famous declaration of the end of metanarratives applies to the seemingly unshakable world of numbers. Lyotard, a key figure in postmodernism, argued that modern society was characterized by these grand, overarching narratives that claim to explain everything, to provide a universal framework for understanding the world. Think of Marxism, Freudianism, or even the Enlightenment belief in the power of reason and progress. Lyotard argued that these metanarratives were collapsing, giving way to a more fragmented, skeptical, and pluralistic worldview. Now, you might be thinking, okay, that makes sense for social theories, but what about mathematics? Isn't 2 plus 2 is equal to 4 always and everywhere true? Isn't math the ultimate metanarrative, the one that transcends culture, history, and individual perspective? That's certainly the traditional view. Mathematics has often been seen as a kind of Platonic realm of pure, eternal truths, independent of human minds. But what if we start to question that assumption? What if we look at the history of mathematics, and the diversity of mathematical systems? Let's take geometry as a prime example. For centuries, Euclidean geometry was considered the only possible geometry, the one that perfectly described the physical world. Its axioms, like the parallel postulate, that parallel lines never meet, seemed self-evidently true. But then, in the 19th century, mathematicians like Lobachevsky, Bolyai, and Riemann developed non-Euclidean geometries. These geometries rejected the parallel postulate, and instead explored spaces where parallel lines could meet, or diverge. Suddenly, the seemingly absolute foundation of geometry was shaken. At first, these non-Euclidean geometries were seen as mere mathematical curiosities, abstract games with no connection to reality. But then, Einstein came along and used Riemannian geometry, a type of non-Euclidean geometry, as the mathematical framework for his theory of general relativity. Suddenly, non-Euclidean geometry was describing the actual shape of spacetime. This is a crucial point. Different mathematical systems can create different realities. Euclidean geometry describes a flat, three-dimensional space. Non-Euclidean geometries describe curved spaces, spaces with different properties and behaviors. And it turns out that the universe itself seems to operate according to non-Euclidean rules, at least on a large scale. This challenges the idea that there's one true geometry, one true mathematics that perfectly mirrors reality. Instead, we have what some philosophers call mathematical pluralism, the idea that there are multiple, equally valid mathematical systems, each with its own internal consistency, and its own potential applications. This doesn't mean that mathematics is arbitrary, or that anything goes. Each system has its own rules, its own logic. But it does mean that the choice of which mathematical system to use depends on the context, on the problem we're trying to solve. It's a pragmatic approach, rather than a search for absolute, universal truth. So, was Lyotard right? Does the existence of multiple, valid mathematical systems represent the end of mathematical metanarratives? In a sense, yes. The idea that there's one, single, all-encompassing mathematical system that perfectly describes all of reality, that's the metanarrative that's being challenged. This isn't to embrace radical relativism, where all truths are equally valid, or invalid. It's about recognizing the limitations of any single system of thought, even mathematics. It's about acknowledging that our understanding of the world is always shaped by the tools and frameworks we use to describe it. The rise of non-Euclidean geometry, and the broader development of mathematical pluralism, can be seen as a kind of mathematical embodiment of Lyotard's insight. It shows that even in the realm of pure thought, the quest for absolute certainty, for a single, unifying narrative, is ultimately an illusion. And perhaps, that's a liberating realization.